Hi guys, Mr. Schultz here as we dive into nth roots. We're going to be making sure that we describe parts of radical expressions. Before we begin, make sure you put your name at the top as well as your period number. So read this inquiry question on your own, and we'll be talking about it in class in a few days. All right. Before we dive into the meat of this topic, we have to actually go over some terminology. For example, what is this sign called? It's called the radical sign. How about this one right here? What's that called? So we're going to call that the index. That tells us, what are we going to do to this number right here, the radicand. So it's kind of like the inverse of the power right here. So if we have two numbers, any two numbers, real numbers that is, a and b, and any positive number n right here, then a to the nth is equal to b. And this is true. You're like, yes, this is true. Then a is an nth root of b. Well, let's prove it. We have a to the n is equal to b. Well, what does that mean? Well, I'm going to simplify for this a right here. And so the opposite of this power to the n, or n to the nth power, is I'm going to find the nth root of both sides. If I do it on one side, I have to do it on the other side. So then these cancel out, and I'm left with a is equal to nth root b. Hey, wait a second. A is an nth root of b. A is nth root b. Hey, it's just this thing that we just said right here. So if I know this, if I'm going to be talking about the square root of 16, I know that I have two answers right here. This is squared, this is an even. I have both positive and I'll have a negative. So I know that negative 4 squared is equal to 16. This is one of my roots right here. So here's a root. But we call this positive 4 squared, which would equal 16. We call that our principal root. Principal root. Well, let's show another one. This non-negative. So this non-negative root. Non-negative root. Make sure it's the non-negative root. We call that the principal root. So write this right here, this something sixth root of 64. 6 is our index. So that means we have something times something times something 6 times, and that will equal one of those x's, or no, this times 6 times itself will equal 64. Well, we actually have two different answers on this if we figure this out. We have a negative 2 to the sixth power will equal 64. That's one of our roots. But then the non-negative root, also known as what? The principal root, would be positive 2. And so we know that something tricky right here is that if it's an even, it doesn't matter if it's negative, it doesn't matter if it's negative or positive. If the exponent is even, a negative times a negative is a positive. And so we're going to get two different answers right here. So let's continue. So let's say we have this nth root of a. Let's pretend that n is going to be an integer. It has to be bigger than 1. So like 2, 3, 4, 5, 6, whatever. We're going to say a is a real number. Keep it simple, okay? If a is bigger than 0, then it has one unique positive and one unique negative real number, real root. Let's pause it for a second. Like we literally just talked about this. Like if we have the sixth root of 64, that's, both -2 and 2. There's two answers there. But if we have if n is odd, so for example, let's put 3, about 3 to the 8th or 3 to the 27, there's only going to be a positive answer. Let's pause it. So there's going to be a positive answer, no negative. So for example, the cube root of 8 is 2. It's not -2 because I'm going to have 2 times 2 times 2. That's equal to 8. But if I did negative times negative times negative, I would get a negative answer. So -2 times -2 times -2 does not equal 8. So this is no, don't do that. It's only going to be positive. So the difference between, like, if you have the square root or cube root, so square root or cube root, if it's even, two answers, positive and negative. If it's an odd, like cube 3, then only going to be one positive answer, no negatives. Next up, if I have a is equal to 0, this one's really nice. I like this one. Watch this. A is equal to 0. There's going to be one real root. Try this out. Put in your calculator. Put the square root of 0. That's 0. So if I did like the fourth root of 0, that'd be 0. The sixth root of 0, that's 0. And the same thing happens for if n is odd. So one real root. So the third root of 0, the fifth root, the 17th root of 0 is equal to 0. So it's going to hit the x-axis when x is 0. All right, let's continue. So we did bigger than 0, we did equal to 0. Now we're going to do less than 0, a negative number. So if a is less than or 0, then there's going to be 0 real roots for an even number or an even n. That's like this. What times what equals a negative number? Well, if we try a positive times a positive, that doesn't work. If we try a negative times a negative, that won't work because that gives us a positive and that gives us a positive. So that doesn't work. So there's going to be 0 real roots. Now there might be imaginary roots, but we won't get into them yet. Now, if n is odd, then if we have -8, so for example, what times what equals -8, then -2 times -2 times -2 will equal -8. So there's, in this case, if we have a -8 here, then we can get an answer. There's going to be one real root. One real root. And it's going to be one negative. So equals one negative root. But, there's going to be 0 positive. 0 positive roots. All right, guys. So that's what we have for right now. I bid you adieu, and I hope you guys have a wonderful day.